Okay, so here we have another manometer problem. This seemed to be a pretty big trouble for a lot of the class, so I'm doing another one a little bit differently as well. In this problem, I'm going to do everything in one full calculation instead of calculating the full value at each different point. So to start off, the question is asking for the point in point A over here in this left little bubble. And what we know is the pressure right here is 0 psig or 0 psfg, either way. And that's just given right here in the problem. So in order to start off, we're going to, the pressure at A, which is the final value that we're looking for, is the starting value, which is just 0, plus 11 feet, which is right here, times the specific weight of that particular fluid that we're going down through, which in this case is this fluid, which is given by gamma A. And so that's, we have the pressure at this point right here. And then we are going to find the pressure right here, which would be minus the distance, which is 6.2 feet, times the specific weight of that fluid, which is 60. So we'll just call that gamma B. And then we are going to find the pressure here, which is the distance. This is going to be plus because we're going down in the negative z direction, and the distance is 4.1 feet times the specific weight of that fluid, which in this case is gamma C. And then we can find the pressure right here, which is 2.1 feet up, so that's going to be negative. Going up makes the pressure go down. So 2.1 times the fluid that we're going through, which is gamma B. And then, so right now we're at this point right here. We know if we calculated this all out, we would have the pressure at this point right here. And now all we have to do is plus 8 gamma A, which is just this distance right here, times the specific weight of that fluid, and that's all there is to it. Now if we just plug in our numbers, we have 0 plus 11 times 80 minus 6.2 times 60 plus 4.1 times 100 minus 2.1 times 60 plus 8 times 80. And if you calculate this all out, you end up getting 1430 psfg. But if you notice in the problem, that's not all that it asks for. It asks for the pressure in psfg, psig. So all we have to do to that is divide by 144. And we end up getting 9.94 psig. And then it asks for the pressure in psia, which is pounds per square inch of the atmosphere. And it is given in the problem that the atmospheric pressure is 14.5. So all that means is P absolute, or P atmospheric, is equal to the pressure in gauge plus P absolute, which in this case is 14.5. And the pressure in gauge we found right here is 9.94. So the P atmospheric is 9.94 plus 14.5, which ends up being 24.4 psia. And the A just stands for atmospheric. There's our answer. Here's our answer, and here's our answer. And that's all there is to it. Hopefully this helped. This was a lot quicker way of doing things, but you can make mistakes this way. If you want to go through the other example that I posted, I calculate each different pressure, and that way is a lot more tedious, but you're less prone to make mistakes. So again, This problem actually gives us the specific weight of each of these fluids. Normally, in a quiz or a test situation, you're going to be given the specific gravity. So it'll be specific gravity equals like 1.5 or something similar to that. And all that means is that whatever fluid that is 1.5 times the specific weight of water. And that's the specific weight of that fluid. So if the specific gravity of, say, YB is not 60 pounds per cubic foot, and the specific gravity is 1.5, you would just multiply 1.5 times 62.4, and you would get just whatever number for that particular thing. A few ones that you'll use often, you'll be given the specific gravity of mercury, which is 13.6, and then you just multiply that times 62.4, and that value would come out to be 848.64, and that's the specific weight of mercury. That is gamma mercury. Another one that is often given is that of oil, which is 0.8. Usually it differs for the different oils, but to find the specific weight of that fluid, of that oil, would be 0.8 times 62.4, which is 49.92 or 50 approximately, and that's gamma oil. You always have to convert these. The specific gravity, you can't just plug this number right here into these manometer problems. You have to take the specific weight, not just the specific gravity. It's very important, and a lot of people struggle with that, so I figured that if I stress that enough, you guys might understand it. So hopefully this helped. If you have any questions, just email me. Let me know if you have any questions.